In this video, I'm going to look at variable acceleration in 2 dimensions. If you're looking for constant acceleration, just click the link below. This example is in 2 dimensions, so I'm going to also scale up back to 1 dimension so you can see the comparison. I'm not going to do 3 dimensions here because it uses the same technique as 2 dimensions, just adding a dimension on. So firstly, the question has a lot of information in it. So I normally take out the key points or values and write them in a list because they're much easier to read, especially when you're looking back through a long question. So I've already done it here, so I'll just go through them for you. The force acting on a particle of mass 5 kilograms, so m equals 5 kilograms, is 20I plus 15 TJ newtons. So I've written the force here. If its initial value is 3I plus 25J meters per second, so that's a condition that we're given. Initial means at time equals 0. So I've written at t equals 0, v, velocity, is 3I plus 25J. Find its position after 3 seconds. Given that, so we're given another condition, its position after 1 second, t equals 1, was 8I plus 7J meters. Now these vectors are written in IJ format, which is much easier to type in a document, but sometimes it's helpful to have them as column vectors because sometimes it's easier to work with them that way. So I'll just convert them all into column vectors. 20I plus 15tj for the force, the velocity of 3I 25j, and the position of 8I 7j. So in the question we're asked to find the position after 3 seconds. Now although we don't have an equation for position, we do have some information to help us find an equation for acceleration, and then we can use the acceleration to find the displacement or position in this case relative to the origin. So if we have an equation for acceleration, we can integrate that to find an equation for velocity, and then integrate that again to find an equation for displacement, or in our case, position relative to the origin. So in 1 dimension, using F equals ma, we can have A, acceleration, equals force divided by mass by rearranging that, and that gives us 4 meters per second squared in 1 dimension. In 2 dimensions, we have force equals 20I plus 15tj, and if we divide that by 5, we get 4I plus 3tj. Now I'm going to write that acceleration as a column vector as well. So A equals 4I plus 3tj. So in 1 dimension, I would integrate acceleration to find velocity. So velocity is equal to the integral of acceleration. Here that's 4 with respect to t, time. So v equals 4t plus a constant of integration. And now to find a constant, we need some conditions linking velocity and time, which we have here. So at t equals 0, v equals 3. So that means that c equals 3, and our new velocity equation is 4t plus 3. In 2 dimensions, we have v equals, and where we had the acceleration before, we're using now a column vector. So the integral of 3t with respect to t. So that means that velocity is equal to, and we just integrate each line as if it were a separate integral. So 4 becomes 4t plus c as before. That's the first dimension. So I haven't changed that, so all the first dimension will be the same as the original here. the second dimension, 3t becomes 3 over 2t squared. And then plus, we need another variable, so we'll use d. And again, in order to find the variables c and d, I need an equation linking v and t, which I have here. So at t equals 0, v equals 3i plus 25j. Now I've got that in a column vector format, which will be more helpful. So v equals 3, 25, okay, and that is equal to, and this is at time equals 0, so 4 times 0 is 0, plus c, and 3 over 2 times 0 squared is still 0, plus d. So c equals 3 and d equals 25. So now our velocity equation becomes v equals 4t plus 3 in the I direction, and 3 over 2t squared plus 25 in the j direction. So going back to the one-dimensional scenario, to find the position vector, we need to integrate velocity. So r equals the integral of velocity with respect to time. So there's velocity from here, and we're integrating that with respect to time. So r equals, integrating this, we get 2t squared plus 3t plus, and I've already used c in this scenario, so I'm going to use d. And to find the variable, the constant of integration d, I need a set of conditions linking r to t, which I have up here. At t equals 1, r equals 8. So 8 equals 2 times 1 squared, which is 2, plus 3 times 1, which is 3, plus d, and that means d equals 5. So our equation for the position will be r equals 2t squared plus 3t plus 5. So now in 2 dimensions, r is still equal to the integral of v dt. So we're integrating this as a column vector. So integrating 4t plus 3, I, 3 over 2t squared plus 25j with respect to time. So r equals, and again I just integrate each row as if it were a separate integral. So 2t squared plus 3t plus, now I've used already c and d for my constants here, so I just need to go on to the next letter, e, for my next constant of integration, and then integrating this, increase the power, and then divide by the power, so it will be a half t cubed plus 25t plus, and I'm going to use f there. And again I need a set of conditions linking r and t to help me find these variables here. So I have at t equals 1, r equals 8i plus 7j, and I'm going to use the column vector format because that ties in with what I'm doing here. So 8i 7j, and then t equals 1, 2 times 1 squared plus 3 times 1 plus e, and a half times t cubed plus 25, so these 25 times 1 plus f, so that gives me again e equals 5 as before, and f now equals negative 18.5. So rewriting the equation, I just need to move my paper a little, I'll have r equals 2t squared plus 3t plus 5i and half t cubed plus 25t minus 18.5j. So the question asks us to find the position after 3 seconds. So if I'm just doing that in one direction, I'll substitute at t equals 3, r equals, and I substitute 3 into that, I get 30 meters. In this scenario, the two-dimensional scenario, r at t equals 3, r equals, and I substitute 3 into this expression here and I get 30. And when I substitute 3 into this expression here, I get 70. So the position relative to the origin is 30, 70. Now, if you want to know what that looks like, if we had just the one-dimensional version, we would just have 30i, which would be a displacement along the horizontal axis. If this was a 2D question, or 1D question, sorry. If it's 2D, now I've added the other dimension, I'm going 30 in the I direction and 70 in the J direction, and so overall that's 76.1 meters at an angle of 67 degrees, just using Pythagoras and trigonometry.